All right, we're looking at statistics, chapter 4, test review. Okay, now in this chapter, one thing we're looking at is discrete random variables. A discrete random variable, and we've got this notation here. Now, this right here is my mean. This is called a mu. MU is how you say this, mu. This is my mean, which is the average. And it's this sigma. This right here means this little sign means you're adding up all these right here. So each x times its probability. So like 1 has a probability of 0.3. 2 has a probability of 0.1. 3 has a probability of 0.4, and so on. So this means I would sum up, or I would add up each x times its probability. So I would do 1 times this, 2 times this, 3 times this, and I would add all those up. That's what this means. Now this right here is my variance, sigma squared. Okay, this is the variance, which means I add up, this is the sum symbol again, which I add up all the different x's minus the mu's squared times the probability of each one. And then here's standard deviation. And standard deviation is the square root of the variance. Okay, and again, this is the summation of each x minus the mu, or minus the mean, squared, times the probability of that x. Okay, and we'll get into those in just a minute. Another thing we had in this chapter was binomial distributions. The probability of exactly x successes in n trials is going to be this right here, where this is a combination of n things, choosing x of them, times p to the x power, and then q to the n minus x power. All right, and then here's how you figure out the mean, the variance, and the standard deviation for that. Okay. Then we had geometric distributions. Geometric is the probability that the first success will occur on trial number x. So like if you're shooting free throws, what's the probability that you make your first one on the 5th try? Okay, that would be a geometric distribution. And so this is how you find the probability of that. P times q to the x minus 1 power, where q is 1 minus p. So in other words, if you hit your free throws on 30%, if you're 30% on shooting free throws, on making them, then 1 minus 30 would be 0.70, so it'd be 70%. So that's what q would be. And then we had the Poisson distribution, which the probability of exactly x occurrences in an interval is this. Okay, where e is the natural base and mu is the mean number of occurrences per interval. In other words, what this means is, suppose that each day a person typically hiccups 5 times. Okay, what's the probability that they hiccup 8 times? Okay, that's what this thing does. Okay, when you have something that normally happens, the average of something normally happening, what's the probability that this other thing's going to happen, or that it might happen again, or whatever. Okay, and we'll talk more about that when we get to some of these examples. All right, so first off here, number 1, decide whether this graph represents a discrete random variable or a continuous random variable. So this is home attendance for football games. Okay, this is discrete. Okay, because they're countable. You have this many people, you have this many people, you have this many people. If it's continuous, there's no way to count them. So this would be discrete. And you can see the answer down here, discrete. Okay. Number 2, decide if this is discrete or continuous. Annual traffic fatalities in a country. All right, this is discrete because you can count these. Continuous, you can't count. All right, basically. All right, let's look at number 3 here. Determine whether this is discrete or continuous. Okay. X represents the height of a randomly selected giraffe. All right, we're looking at the height. This is a measurement. This is something we can't count. So this is continuous. Now we've got a couple different things that say continuous. So if you look at it, this is a countable number of possible outcomes. No, you can't count them. No, it's uncountable. So this would be B. Okay, you can see it down here. That's the answer. Okay. Number 4, decide whether this is discrete or continuous. Let X represent the temperature of a person taken with a mercury thermometer. All right, this is continuous. You can't count this. It's a measure. If you have a measure, that is going to be continuous. There's so many different things this could be. Your temperature could be 98.7. It could be 98.75. It could be 98.6. So there's too many to count. It's uncountable. All right, so that would be continuous. So that's the difference between discrete and continuous. Discrete you can count. Continuous is a measure or something that you can't count. All right, number 5. Using the data, determine whether it would be unusual for a household to have no HD televisions. Okay, so here's 0 HD televisions right here, and this is your probability. Now, this would be unusual because, see, if it's less than, 0.05 is the cutoff. If it's less than this, then that's considered unusual. All right, so it would be unusual. So it's either A or D here. The probability of having H is less than this. I think it's A. This says, yeah, it's A. This down here is ignorant. So the answer is A. Okay. Now 6 here says, determine the required value of the missing probability to make the distribution a discrete probability distribution. All right, so we've got one missing here, right there. All right, so what we need to do is we need to add these other ones up. So if I add these up, 3 plus 6 is 9, plus 8 is 17. 1, 4, 5, 77. So when I add these up, I get 0.77. Okay, now I do 1 minus that, which is 0.23. So this missing one right here has to be 0.23. And you can see the answer right there. So we're in good shape. Okay, they have to equal 1. Now here's one. Decide if this one is a discrete probability distribution. All right, well, a couple things about it is when you look at your probabilities, they all have to be positive. You can't even negative ones. So these are all positive, and they have to be between 0 and 1, which they are. And then I should be able to add them up, and it should add up to 1. So if I add these up, 9, 10, that's 20, 2, carry my 2, 2, 4, 8, 10. So it adds up to 1. So I think we're good here. This is the probability sum to 1, and all are between 0 and 1 inclusive. I think it's A. Okay. All right, number 8. Number 8 here. Determine whether this is a probability distribution. All right, so look and see if they're all between 0 and 1, and they are. Okay. Now let's add these up. All right, so I'll just use the calculator, I guess. So I'm going to type in 1/2. 1/2 plus 1/10 plus 1/25 plus 3/4 plus 1/50 plus 1/5. And look there, I got 1.61. It does not equal 1, so no. It's a no, but it's not because they have greater values than 1 or less than 0. Right here, the probability is not equal to 1, so the answer is D. Okay. All right. What about this one here? Complete parts A through A and B. The number of dogs per household in a small town, so 62.9% have no dogs, and so on. Find the mean, the variance, and the standard deviation of the probability distribution. All right, so we've got this right here. These are my formulas I'm going to be using. All right, so my mean is going to be the average. I'm going to sum up each x times its probability. So basically what I'm going to do is 0 times this plus 1 times this, 2 times this, 3 times this, 4 times this, 5 times this, and add all those up. Okay? That's what this means right here. I'm going to add up each x times its probability. Each x, 1, 2, 0, 1, 2, 3, 4, 5, times its probability. All right, so 0 times that is going to be 0, so I'm not even going to punch that one in. 1 times 0.226 plus 2 times 0.094 plus 3 times 0.027 plus 4 times 0.015 plus 5 times 0.010. And I get this here, 0.605, which it says round to 1 decimal place, so 0.6 is what I'm getting. And that's the answer down here, so we're good. All right, now we got to find the variance. Okay, now for the variance, bring this back over here. For the variance, I got to sum up each x minus the mu, square that, times its probability. So let me hold this on here. So I'm going to take each x, so I got 0 through 5. So I've got 0, 1, 2, 3, 4, 5. Okay, so for this one I'm going to do 0 minus the mu, which remember is 0.6. I'm going to square that, and I'm going to times it by its probability, which was 0.629. And that's what I'm going to do for each one. So right here I'm going to do 1 minus 0.6 squared times its probability, which is 226. Then I'm going to take 2 minus the mean squared times 2's probability, which is 0.94. All right, then 3, I'm going to do 3 minus the mean squared times 3's probability, which is 0.027. Then 4 minus the mean squared times 4's probability, which is 0.15. Sorry, I think I pushed that up there. All right, then I'm going to take 5, the last one here, minus the mean squared times 5's probability, which is 0.10. 0.010. Okay, and so I'm going to do all these, each one, and then I'll add all these up. Okay, so starting with this one, 0 minus 0.6 equals, square it, equals, times 0.629, and I got this right here, 0.22644. Okay, now I'm going to do this one. 1, clear it off, 1 minus 0.6 equals, square it, equals, times 0.226. And I got this right here, 0.03616. Okay, then I go to the next one now. Okay, I'm going to have 2 minus 0.6 enter, square it, equals, times its probability, which is 0.094. And that comes up to 0.18424. Okay, we're halfway home. All right, so now here I'm going to take 3 minus 0.6 equals, square it, equals, times the probability of 0.027. And I got 15552. All right, then I'm going to take 4 minus 0.6 equals, square it, equals, times 0.015. And that's going to be 0.1734. And now the last one here, 5 minus 0.6 enter, square it, equals, times 0.010. and I got 0.1936 there. And now I add all these up. Okay, so 0.22644 plus 0.03616 plus 0.18424 plus 0.15552 plus 0.1734 plus 0.1936. And this is what I got here, 0.96936. This is my variance. Okay, now it says round to 1 decimal place. So if I round this to 1 decimal place, this 6 will make the 9 go up to 10, which is 1.0. Okay, which is right. See, we got that right. And now I do the square root of that answer, which when I do the square root, I'm going to get 1.0 also. So there you go. There's my standard deviation. Now part B says interpret the results. Okay, now what this means is they on average have 0.6 dogs and the standard deviation is 1 dog. All right, so which one says on average? Average 0.6. Right here, C. On average, they have 0.6 dogs and the standard deviation is 1 dog. Okay. All right, let's go on to number 10 here, which I think you got the same thing to do here. Okay, so I get a piece of paper here, and I'll try to do a little better on this one here. See if I can keep it on the screen better. All right, so we're going to do the same thing. We're going to find the mean, the variance, and the standard deviation. So for the mean, I'm going to take 0 times this, plus 1 times that, 2 times that, 3 times this. All right, so I'm just going to punch that in. Okay, so 0 times this is 0, so I won't worry about that one. All right, 1 times 0.303 plus 2 times 0.244 plus 3 times 0.137 plus 4 times 0.039 plus 5 times 0.016, and I got this right here, 1.438, and it says round 1 decimal place, so 1.4. Okay, and look there, we're good. We got 1.4. All right, the variance. All right, now the variance, I gotta do 0 minus this, square it, and then times it by that. Okay, so let me write it down. 1.4, I'm gonna do 0 minus 1.4, square it, and then times it by 0.261. All right, then I'm gonna do 1 minus 1.4, square it, and then do 0 times it by 0.303. And I'm going to do 2 minus 1.4, square it, times 0.244. And I'm going to do 3 minus 1.4 and square it, and I'm going to times that by 0.137. And I'm going to do 4. Okay, I'm getting off the screen here. Minus 1.4 squared, and then times it by 0.039. And then I'm going to do 5 minus 1.4 squared times 0.016. All right, so I'm going to do all these. Okay. All right, so I'm going to do 0 minus 1.4, enter, square it, enter, times 0.261, there you go, 51156. Okay, now I'm going to do 1 minus 1.4, enter, square it, enter, and then times it by 0.303, and I got 0.04848. 0.04848. Okay. These are equals right here, I guess. I should put them on there. All right, now I'm going to do 2 minus 1.4, enter, square it, enter, and then times it oops, hit divide, times it by 0.244. There you go, 08784. 0.08784. All right, now I'm going to go to 3 here. 3 minus 1.4, enter, square it, enter, and then times it by 0.137, and there you go, 35072. Okay, and we'll do 4 here. All right, so watch me there. 4 minus 1.4, enter, square it, enter, times 0.039. And that's 0.26364, 0.26364. And then the last one here, I got 5 minus 1.4, enter, square it, enter, times 0.016. And I got 20736. All right, now add all these up. Okay, add all those up, and that would be my variance, which I put the sum thing here. If I'm going to sum those up, my variance is going to equal this sum. Okay, so let's go here. 0.51156 plus 0.04848 plus 0.08784 plus 0.35072 plus 0.26364 plus 0.20736, and I got this right here, 1.4696. Now if I round that to 1 decimal place, I get 1.5. So 1.5 is my variance. Look there, we got it, man. We're in good shape. Now my standard deviation, now I'm going to keep this on here. I'm just going to use that to calculate the standard deviation, which would be the square root of that answer. Well, I messed up. The square root of that answer is 1.2. Okay, and look here, we got 1.2 down there. We're in good shape. Now interpret what this means. All right, the mean is 1.4. So the average batch of 1,000 machine parts has, okay, see, this is defects per 1,000 machines. So the average batch of 1,000 machine parts has 1.4 defects. The standard deviation is 1.2. So the typical number of defects in a batch of 1,000 okay, here's my answers down here. It deviates right here. It deviates from the mean about 1 defect. I think it's this one right here. Because see, it's 1.2, so it's going to deviate from the mean, which means, you know, you're not going to have 1.4 defects. You might have 1 or you might have 2, but this is going to vary between, if you add, basically here's what it is. My average is 1.4. It's going to deviate 1.2 this way and 1.2 this way, which means 1.4 minus 1.2 is 0.2. And then 1.4 plus 1.2 would be 2.6. This means basically it's going to deviate from 0.2 to 2.6, these defects, on average. Now, we can't necessarily have 0.2 defects, but this is what it averages out to. Okay. All right, number 11. Find the mean variance standard deviation of the binomial distribution. All right, this is a binomial, so these are our notes for binomial. Okay, the probability is going to be n choose x, p to the x, and then q to the n minus x power. All right, what that means is in here, n is 60, p is 0.3. Okay. All right, it's just asking for the mean, so we don't have to find the probability. So the mean, I'll bring this paper back on here. The mean is just n times p. Here's my n, there's my p, so I just multiply those two. So when I do that, get 18. And you see the answer down here. The variance, all right, bring us back in. The variance is going to be n times p times q. N times p times q. All right, here's p right there, 0.3. So q is going to be 1 minus 0.3, which means that's 0.7. All right, so I'm going to do n times p times q. And this right here, this is 60. This right here is my variance. Okay, so let's bring my calculator in. I'm going to do 60 times 0.3 times 0.7, and I get 12.6. That's my variance. And you can see we're in good shape down here. The standard deviation is going to be the square root of that. So I just simply go the square root of that answer, and this is 3.549, which we round it to one place, 3.5. And there you go. Okay. Here's another one, number 12. Doing the same thing. So the mean, all right, is going to be, the mu here is going to be 123 times 0.63. It's going to be n times p. All right, so I'm going to do 123 times 0.63, and I get 77.49, 77.5 around to the nearest tenth. Okay, which that's what we got down here, so we're good. All right, now the variance, all right, the variance is going to be n times p times q. So it's going to be n times p times q, which q is 1 minus this. Let's do that up here. 1 minus 0.63 is going to be 0.37. So that's my q. N times p times q. All right, let's see here. Oops. There you go. I got 28.67, which is 28.7. What you can see, we got that down here, so we're good. Now, leave this on here and calculate. See, that's what my variance is, but I rounded it for the answer. But use this to calculate the standard deviation. So do the square root of that answer, which is 5.35, which is be 5.4, which is what we got down here. All right, so that's what we got going on there. All right, number 13, 69% of U.S. adults have very little confidence in newspapers. If you randomly select 10 U.S. adults, find the probability that the number of U.S. adults who have very little confidence in newspapers is exactly 5. Okay. All right, so we're going to find the probability that we have 5 exactly people that have little confidence in newspapers. Okay. Now, if you remember, there's let's see, there's 10 adults here. So there's going to be 10 C5. Okay, I'll show you my, right here. This is my formula right here. I'm going to do 10 C5 times p to the x power, and then q to the n minus x power, which means, see, this number here and that number there are both x. So see the number 5 here? So this is going to be p to the x, or p to the 5, rather. And then I'm going to have q to the 10 minus 5, which is also 5. I don't know what I'm doing. Write this again. So p, probability of 5, is going to be 10C5. I don't know why I didn't write the numbers in there. And my p is 69%. So I'm going to do 0.69 to the 5 power. Okay. Then I'm going to do 1 minus 0.69. 1 minus 0.69 is 0.31. Here's my q. So 0.31, and I do 10 minus 5, which is also 5. So that's what I'm going to type in the calculator. Okay. All right, so we're going to have 10, and then remember this is how you do your NCR, 5 times 0.69 to the 5 power times 0.31 to the 5 power. And I got 0.1128. Let's see here, what do we round it to? 3 places. So the 8 makes the 2 go up to 3. 1, 1, 3. 1, 1, 3. Okay, look here, we got it. We're in good shape. All right, now this is probably that x is greater than or equal to 6. Okay, x is greater than or equal to 6, which means we want the probability of 6, with the probability of 7, probability of 8, probability of 9, and probability of 10, because we had 10 people that did this. So greater than or equal to 6 means 6 through 10. And I want to find the probability of each one of these and then add those up. All right, so now what I'm going to do here now, this is going to be 10C6. And it's going to be 0.69 to the 6th power. This is a 9. And then 0.31 to the 10 minus 6 power, which would be 4 power. Okay, that's the probability of 6. Okay, probability of 7 is going to be 10C7. 0.69 to the 7 power, 0.31 to the 10 minus 7, which would be 3 power. Okay, probability of 8, it's going to be 10C8. This would be 0.69 to the 8 power, and this would be 0.31 to the 10 minus 8, which would be 2 power. Okay, 9 would be 10C9. 0.69 to the 9 power, and then 0.31 to the 10 minus 9, which would be 1 power. You see how these numbers are going up and these numbers are going down? This last one will be 10C10, 0.69 to the 10 power, 0.31 to the 0 power. 10 minus 10 is 0. And then I'm just going to type these in. Now, remember, what we've done before, we just typed the first one in. Let me just go back and just change these couple numbers. So let's type this first one in here. Actually I had it on there from the previous problem. So let's just go in there. All right, so I'm going to change this 5 that's in here to 6 because it's 10C6. And this is 0.69 to the 6 power. And then this should be to the 4 power. All right, there you go. So this we got 0.20929. I'm going to go 5 places there. Okay, so it won't round too bad on me. All right, now I'm going to go back in, and I'm going to change this 6 to 7. I'm going to change this 4 to 3, and I'm going to change this 6 to 7. So I'm just going to change those 3 numbers. So just go back to your problem, and that turns into a 3. Going back to this one here, that turns into 7. And then I'm going to go back to this number here, and that turns into a 7. And there you go. 0.26620. Okay. And now I'm going to change 3 to a 2, 7 to an 8, and 7 to an 8. So that's a 2. That's an 8. Oops. And that's an 8. 0.22219. Okay. And then I'm going to change those numbers just like I've been doing. So this right here changes to a 1. This number changes to a 9. And this number changes to a 9. And that's 0.10990. And then the last one here, okay, I'm going to change this to 0. Change this right here to a 10. I'm going to change this to a 10. And there you go. And now I add all them up. Okay. All right, so I already got this on the calculator now, so I'm going to add 0.10990 plus 0.22219 plus 0.26620 plus 0.20929. And I got this right here, 0.8320. I think rounded at 2. See there? Rounded at 3 places, 0.832. And there you go, man, we got it. All right, now find the probability that it's less than 4, which means if it's going to be less than 4, 0, 1, 2, and 3. I got to get these 4 and add them up. So like this 0, this is probability of 0. That's going to be 10C0 times 0.69 to the 0 times 0.31 to the 10 minus 0 is 10. Okay, and right here I'm going to have 10C1, 0.69 to the 1 power, 0.31 to the 10 minus 1, which is 9 power. This will be 10C2, 0.69 to the 2 power, 0.31 to the 10 minus 2, which is 8 power. You see how these are going down, these are going up. And this will be 10C3, 0.69 to the 3 power, 0.31 to the 10 minus 3, which is 7 power. All right, so I'm going to type these in. I kind of keep going uphill here on this. Okay, so I still have this in my calculator here, so I'm going to go 10 here. Make that a 0 there and a 0 here. All right, that's going to be, ooh, man. 0 point, or this moves back 6 places, so it'd be 5 zeros. 1, 2, 3, 4, 5 zeros, and 8, 1, 9. All right, now I'm going to go back in there. I'm going to change this to a 9. Change that to a 1. And change it to a 1. And that's going to be 1, 2, 3, 1, 8, 2. All right, I'll go back in there. And I'm changing this to 8. Change it to a 2 right there. Change it to a 2 right there. And there you go, 0.001827. And then one more. Change it to a 7. Go in there and change this to a 3. And change it to 3. And I got 0.01084. 5. All right. And now I add those up. We'll sum them up. All right, so I got this one on the calculator still, so plus 0.001827 plus 0.000182 plus 0.0000819. And that's what I get right there, 0.012. The 8 makes the 2 go up to 3. 013. And look at there. This is what we got, man. So we knocked it out of the park. Okay. Now here's another one. We'll go through it. If you think you got this, you don't want to watch this part, fast forward over it, you know? No big deal. All right, so 19% of adults, there's my P, favor the use of unmanned drones by police agencies. 12 U.S. adults. We got 12 adults randomly selected. Find the probability that the number of U.S. adults who favor the use of unmanned drones by police agencies is exactly 3. So we want to find the probability of 3 here, which means we've got 12 adults, and we're going to select 3 of those. My probability is 0.19, and that's going to be the 3 power. And then I do 1 minus that. 1 minus 0.19 is 0.81. That's going to be 12 minus 3, which is 9 power. So there's how I type it in, okay? So again, where the numbers go, there's 12 adults that are selected, or what's the probability that 3 of them favor this use of unmanned drones? So 12C3, this is going to be 0.19 to the 3, and then 0.81 to the 9. 12 minus 3 is 9. So, oops. All right, so let's type her in here. So I'm going to do 12 NCR3 times 0.19 to the 3 power times 0.81 to the 9 power, and I got 0.226. Look there, we're good. Okay. Now, what's the probability that it's greater than 4? Okay. I'll tell you what I'm going to do here on this. Since it's greater than 4, that's, look here, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's all these right there. Okay. I think it would be better if I did 0, 1, 2, and 3, and then just do 1 minus that answer, and I would have all them. It'd be a lot easier. See? Instead of doing 4, 5, 6, 7, 8, 9, 10, 11, and 12, I'm going to do 0, 1, 2, and 3, and do 1 minus that, and that would be the probability of that. Okay? So that's what I'm going to go for on this one. All right, so and I've already done 3, so 0, 1, 2, and 3. I'm going to do the probability of each of these. I don't think I necessarily wrote all this out a while ago. We've already done this one. That was 0.226. Okay. Which I had it wrote out. Well, we'll go ahead and write these other ones out. So there, this one is going to be 12C0 of 0.19 to the 0, and then 0.81 to the 12 minus 0 is 12. Okay. Then right here I'm going to have 12C1, 0.19 to the 1 power, 0.81 to the 12 minus 1 is 11 power. And this is going to be 12C2, 0.19 to the 2, 0.81 to the 12 minus 2, which is 10. And so I'm just going to type those in. I still have this on my calculator from the previous problem, so I'm going to make this a 12. I'm making that a 0. I'm making this a 0. And that probability is 0.79766. All right, now I'm going to go in there, and again, I'm going to change this 12 to 11. I'm going to change this 0 to a 1. I'm going to change this 0 to a 1. All right, so that's basically what I'm doing here. So I'm going back in my problem here. I'm making that an 11. Okay. I'm making that a 1. Making that a 1. And that's 0.22452. And then I got one more. I'm going to change this to a 10, change it to a 2, and change that to a 2. All right, so make that a 10, 2, and 2. And there you go. 0.289668. All right, so I add all these up. Okay, so here's this one here. I'm going to bring over here 0.226. So I'm going to add those up. All right, so okay, we got something wrong. Because the reason I know something's wrong, I add it up, I get more than one. All right, let's look at this first one here. Maybe we have something wrong on it. Let's type in 12 NCR 0 times 0.19 to the 0 times 0.81 to the 12. Oh, yeah, there's my problem. That's 0.07. I left the 0 out. Okay, so I checked that and found, see, it added up to more than 1. It can't be more than 1, and that was my problem. I left a 0 out, and you probably saw it when I did it a while ago. So plus 0.22452 plus 0.289668 plus 0.266. Uh-oh. hit 266 in 0.2 instead of 0.226, so I'm going to do it again. I'm messing up this problem. All right, so I got 0.8199. Okay, 54. That's what my calculator says. All right, now remember, we did these right here. We're supposed to be doing that. So I need to do 1 minus this for my total answer. All right, so if I do minus 1, it's going to be negative, which means it's positive, but 0.18. 0.18 is what I'm getting, which is what my answer is down there. So I'm in good shape. Now, this last one here, what's the probability that x is less than 8? Less than 8 would be 0, 1, 2, 3, 4, 5, 6, and 7. So I need to add all those up. All right, now I just did 0 through 3. Okay, 0 through 3, we just did that right here. And so 4, 5, 6, and 7, I need to add those up. Okay, so 0 through 3, we just did that. That's 0.819954. Okay, so here we want to find the probability that x is between 0 and 7, which means now, again, they favor the unmanned drones by the police. There's 12 adults chosen. So what's the probability that there's less than 8, which means 0 through 7? All right, so I need to add all these up. Well, I just did these. Okay, no sense in doing it twice. So there's what that is, 0 through 3. Now I need to do the probability of 4. Okay, 5, 6, and 7. I need to find those answers and add it to this. Okay, now I suggest writing it down. I don't want to put it in the calculator. So this is going to be, there's 12 people. We want 4. This is 0.19 to the 4, and this is 0.81 to the 12 minus 4, which is 8. Okay, again, here's my P right there, 0.19, and then 1 minus that is my Q, which goes there. This is going to be 12C5, 0.19 to the 5, 0.81 to the 12 minus 5, which is 7. 12C5, 0.19 to, I'm sorry, this is 6. 0.81, 12 minus 6 is 6. And this is 12C7, 0.19 to the 7, and then 0.81 to the 12 minus 7, which is 5. All right, so I'm going to punch those in. Now, this one I've already got it, so. And I still have this thing in my calculator here, so. All right, I want this right here to be an 8. I want this right here to be a 4. And I want this right here to be a 4. Again, I'm just changing these numbers from the previous problem. And when I do that, I get 0.11953. Okay, now change my 8 to 7, change the 4 to 5, change the 4 to 5. Okay, so 7, 5, 5, and I get this right here, 0.04486. Changing those numbers here. This to a 6. They're all 6s. And on this one, I get 0.012277. And then this is the last one here. I'm going to change that to a 5, 7, 7. So I'm changing to 5, 7, and 7. And then I got 0.002468. All right, now add these up. Now remember, they're adding this one with it. Okay. This is the probability of 0 through 7. All right, so 0.819954 plus 0.11953 plus 0.04486 plus 0.012277 plus 0.002468, and here we go, 0.999089, which is almost, that's like 1. So if I ran to the nearest tenth, it is 1. And there you go, you can see it right there, 1. So basically what that means is it's going to, if only 19% favor these drones, if you get 12 people, it's going to be less than 8. It's going to have in favor of this. So that's it. All right. Now 15. 36% of U.S. adults say they are more likely to make purchases during the sales tax holiday. You randomly select 10 adults. All right, this is the same problem, basically. I'm just wondering, time's really getting short. I'm going to leave that one, let you guys do it. Let's go to 16. 38% of working mothers do not have enough money to cover their health insurance deductibles. You randomly select 6 working mothers and ask them whether they have enough money to cover their health insurance deductibles. The random variable represents the number of working mothers who do not have enough money to cover their health insurance deductibles. Complete parts A through C. Okay. So we're selecting 6 working mothers and ask them, we got the same thing here. All right, so this is going to be of the 6 C0, and then my P is 0.38 to the 0 power, and then 1 minus 0.38 is going to be 0.62, and that's going to be 6 minus 0, which is 6. So there's what I type in for this one. This is going to be 6C1, 0.38 to the 1 power, 0.62 to the 6 minus 1, which is 5 power. And then I just continue on going down through there. Okay. My video's getting lengthy, so I think I'm going to let you guys do this one. Okay? If you have questions about it, let me know. All right. We're going to 17 because we don't have a whole lot of time. It's already been 52 minutes. All right, 79% of U.S. adults think that political correctness is a problem in America today. You randomly select 6 U.S. adults and ask them whether they think political correctness is a problem in America today. The random variable represents the number of U.S. adults who think that political correctness is a problem. Answer questions below. Find the mean of the binomial distribution. Okay, now remember, your mean is going to be n times p. So my n is 6 and my p is 0.79. So 6 times 0.79. Six times 0.79 is 4.74, which is 4.7. Okay, we got that right here. All right, the variance. Okay, now here's your notes. The variance is n times p times q. Here's n times p. Q is going to be 1 minus 0.79, which is 0.21. All right. So that's going to be 0.9954, which would be 1. See there? This 9 makes it 9 go up to 10, which make it a 1.0, which we can see that right here. Good. And the standard deviation, I do the square root of that answer, which comes out to be 1.0. So we got that. Interpret the results. Most samples of 6 adults would differ from the mean by no more than 1. And what that means is most adults are going to be within 1 of this average. So here's my average. That means if I subtract that, 3.7, if I add it, 5.7, so here's the range most people are going to be in. Most people be between 3.7 and 5.7. Okay. Now 18, we got a geometric distribution. Or it says assume if it applies. Okay. Yeah. Use given probability of success P to find the indicated probability. So here's my piece of 3 when P is 0.70. Okay. Find the probability. Okay. Now, if you remember on geometric, P of x equals P times Q to the x minus 1 power. So what this means is here, okay, so P of 3, in other words, this means like on the third time this finally happens. The success is on the third time, okay? So my P is 0.70, and then 1 minus that, 1 minus 0.70 is 0.30. So this is going to be 0.30, and it's going to be 3. Okay, I guess it'd be to the 2 power. Since it's 3, it'd be, yeah, 3 minus 1 was 2. All right, so let's get this 0.7 times 0.3 to the 2 power is 0.063. Okay. All right, this is a Poisson distribution with the mean is 4. What's probably that x equals 7? Okay, if you remember on Poisson, we have this right here. It's mu to the x power, e to the negative mu power over x factorial. Okay, so what that means here on number 19, okay, the probability that we do 4 is going to be, I'm sorry, 7. 7, probably a 7. All right, so it's going to be 4 here to the 7 power times e to the negative 4 power divided by 7 factorial. Okay, so we're just using this right here. We're mu to the x power, so mu is 4 to the 7 power. And then I have e to the negative mu, which mu is 4, so negative 4, and then x factorial there in the bottom. And so I just punch this in the calculator. All right, so I have 4 to the 7 power times e to the negative 4 power, and then divide by 7 factorial. And that's going to be 0.05954. It says round 4 places, so 1, 2, 3, 4. This 4 makes the 5 stay, and so it's 0.595, which you can see that right there. Okay. Number 20. Find the indicated probabilities using geometric distribution, the Poisson or the binomial. So it's one of those. Assume the probability that you will make a sale on any given telephone call is 0.24. Find the probability that you make your first sale on the 5th call. All right, so that tells me right there it's geometric. Because you're going to make your first sale. The first success will be on the 5th trial. Okay, so I'm going to get that page to show you guys the formula. Oh man, my note I was going to put on there for you. Oh, here it is, up here. All right, so this is geometric right there. All right, where we're going to do P times Q to the x minus 1 power. All right, so my P is 0.24. And then 1 minus that is 0.76. Since it's the 5th call, 5 minus 1 would be 4. Okay, so 0.24 times 0.76 to the 4 power, and it's 0.0800. And look there, we're good. Probably need to make your first sale on the 1st, 2nd, or 3rd call. Okay, so we want to do probably it's on the first call, probably it's on the second call, or probably it's on the third call. So it's one of these right here. So this is going to be 0.24 times 0.76 to the 1 minus 1, which is 0 power. This is 0.24, 0.76, 2 minus 1, which is 1 power. And 0.24, 0.76, 3 minus 1 is 2 power. And so I'll just punch those in and add them up. Okay? Now what I'm going to do here this time, I'm going to punch this all at one time. So I got this times this, plus this times this, plus this times this. Hit the equals, and that should give me my answer. Okay, so that's what I'm going to do all at one time here. So 0.24 times 0.76 to the 0 power, plus 0.24 times 0.76 to the 1 power, plus 0.24 times 0.76 to the 2 power, 0.561. Which we see that right here, so we're good. Okay. This C says, probably you do not make a sale on the first 3 calls. All right, here's how we make a sale in the first 3 calls right there. So if I do 1 minus that, that'd be probably I don't make the sale in the first 3 calls. So that's going to be 439. And look there, we got it. Now, which of these events is unusual? None of them are less than 0.5, so none of them are. So this is D. None of these are unusual. Okay, 21. All right, we got to figure out if this is geometric, Poisson, or binomial. The mean number of births per minute in a country in a recent year was about 8. That's my mu. Find the probability that the number of births in any given minute is exactly 6. All right, this is a Poisson. This is a Poisson where we normally have this average, but now we want to see what the probability if this much happened. So see, normally we have 8. See, 8 births per minute. What's the probability that we have exactly 6? Okay. All right, so this is going to be probably that we have 6. Okay, so it's going to be 8 to the 6th power times e to the negative 8 power divided by 6 factorial. All right, this is my mu. It goes here and here, and then my x goes here and here. Okay, so right there, my mu goes here and here, my x goes there and there. All right, so I just punch in the calculator. So 8 to the 6th power, and then I have e to the negative 8 power, and then divide by 6 factorial, which is 122.122. And oh, we're supposed to do it 4 places. 0.1221. Okay. All right, there you go, 0.1221. All right, now B says at least 6, so that means 6 or more. Okay, so 6 or more goes on forever. 6 or more. That goes on to infinity. We can't add all them up, so we're going to have to do 0 through 5, find the probability of that, and then do 1 minus it. To do 1 minus the probability of 0 through 5 to do this problem. Because this says at least 6, which means 6 or more. Okay? So, have to do probability of 0, probability of 1, probability of 2, probability of 3, probability of 4, probability of 5. Okay? So this is going to be 8 to the 0 power, e to the negative 8 power, divided by 0 factorial. Okay, this is going to be 8 to the 1 power, e to the negative 8 power, divided by 1 factorial. This is going to be 8 to the 2 power, e to the negative 8 power, divided by 2 factorial. You see what's changing is these 2 numbers right here, the zeros. Okay, This is going to be 8 to the 3 power, e to the negative 8 power, divided by 3 factorial. This is going to be 8 to the 4 power, e to the negative 8 power, divided by 4 factorial. This is going to be 8 to the 5, e to the negative 8, divided by 5 factorial. And so I type all those in. Okay. I'm not going to punch this all in at one time, though, because it's going to be too many places to make a mistake. So that'd be 0. Then I have e to the negative 8 power, and then divide by 0 factorial. So I punch this in one time here. This is 0.00033354. And now I'm going to do is I'm just going to change this 0 to a 1, and I'm going to change this 0 to a 1 in my calculator here. So 1, 1. And that comes up to 0.00268. And now I'm going to change these to 2's. So go back in there, change my 1's to 2's. 0.010734. Change them to 3's now. This is going to be 0.028626. Change them to 4's. This is going to be 0.05725. And now for the last one here, change them to 5's. And this is 0.091603. And now I add all them up. Okay. I already got this one on the calculator, so plus 0.05725 plus 0.028626 plus 0.010734 plus 0.00268 plus 0.0003354. And I got this right here, 0.19122. And so I think it's going to be 1912. Okay, now, so this is 1912. Now I got to do 1 minus that. Okay, because remember this is 6 or more. We did 0 through 5. So now 1 minus that is going to be 0.8088. 0.8088. And look there, got it. All right. Now this says more than 6. All right, now what we just did there was 6 or more. Okay? This says 6 or more. This says more than 6. So what I need to do is I need to figure out what the probability of 6 is and subtract it off from that. Find the probability of 6. So I still have this on my calculator. I'm just going to go up in here, and I'm going to change those 5's to 6's. And I get this, 0.290519. And so now I'm just going to subtract this from that. And I get 0.5183. I don't think I got that right. Let me do this again. Yeah, I didn't change all my numbers. This would be 0.122138. So now if I do, all right, there you go, 0.6867, which is what we have right there. Okay. So this is 0.6867. Now, which one of these is unusual? No, none of them. So none of them are. Okay. All right, this is number 22. Newspaper finds that the mean number of typographical errors per page is 8. Find the probability that exactly 5 typographical errors are found on a page at most 5. All right, this is Poisson. There you go. This is Poisson again, because we normally have an average of something, and we want to see what the probability is if this happens. So normally, see, we have an average of 8. This is my mu right here. Okay, what's the probability that we have 5? All right, so this is going to be the probability we have 5 is going to be 8 to the 5 power times e to the negative 8 power divided by 5 factorial. Okay, now how you know this is Poisson is because you normally have 8 on average. Now it's wanting to tell what the probability if you had 5. So 8 to the 5 power, then I have e to the negative 8 power, and then divide by 5 factorial. And that's going to be 0.0916. All right, looks like we got it. Okay. Now, part B says that probably at most 5 typographical errors are found. At most 5. So that means 5 or less. Okay. What we're going to have to do here, we're going to have to do 0, 1, 2, 3, 4, 5. We need to do all these and add them together. All right, so this is going to be right here, 8 to the 0 power, e to the negative 8 power, divide by 0 factorial. Okay, this would be 8 to the 1 power, e to the negative 8 power, divided by 1 factorial. And you see just all it's changing is the zeros to 1s. So this would be 8 to the 2, e to the negative 8, 2 factorial. This is 8 to the 3, e to the negative 8, divided by 3 factorial. This would be 8 to the 4, e to the negative 8, divided by 4 factorial. And this is going to be 8 to the 5, e to the negative 8, divided by 5 factorial. And so I punch those in. Okay, so 8 to the 0 power. Then I have e to the negative 8 power. And I'm going to divide by 0 factorial. Okay, all right, so it all looks good. All right, so here's what I get here. 0.000334. All right, I'm going to go up there and change my zeros to 1s. This is a 0.00268. I'm changing my 1s to 2s. See, all I'm doing now, changing my 1 to a 2 here, changing this 1 to a 2 there. So let's go back in there, make that a 2, make this one a 2, and there you go. 0.01073. All right, right here, we're going to change them to 3s. And there we go, here's 0.028626. This is going to be 0.0572522. And this one is 0.091603. And now add all them up. Okay. All right, so I already got this on the calculator, so I'm going to plus, I'm going to just go up, so 0.05775, or 72, that's 2522, plus 0.028626 plus 0.01073 plus 0.00268 plus 0.0003354, and I get this right here, 0.19122, which is 1912. And look here, man, we got it. All right, now the last one here, C. More than 5 typographical errors are found on a page. So that's more than 5. So that's greater than 6. Greater than or equal to 6. Okay. All right, now what we just did there, this is more than 5, all right? We just did 0 through 5. This is the probability of 0 through 5. So more than that, I just do 1 minus this. So hey, this is an easy problem. I'm going to go 1 minus that 0.1912, which is going to be 0.8088. And look there, we got it right there. Okay. All right, which of the events are unusual? No, none of them are. So this is none. Remember now, to be unusual, it's got to be less than this. Okay, now this is the last problem here. And this is another binomial one. Okay, player completes a pass. No, this is not binomial. He completes a pass 68.8% of the time. Find the probability that the first pass he completes is the second pass. Okay, that's geometric. The first success is on the, what is it? The second pass. So we're going to do this right here. So this is going to be 0.688 times, I got to do 1 minus that, which is 0.312. And then since the second one, 2 minus 1 is 1. And I'm going to punch that in. So this is going to be 0.688 times 0.312 to the 1 power, which is 0.21456. Around 3 places, so 0.215. There you go, we got it. Okay, the first pass he completes is the first or second pass. Okay. All right, so we just did the second one here. Probably it's on the first, or probably it's on the second one. This one we just did, which was 0.215. Now the first one is going to be 0.688 times 0.312. And then 1 minus 1 is 0 power. Okay. And then I just add these two together. So this right here is going to be 0.688. And now I add these two. So I get when I add them up, I get 0.9026, which is 0.903. Which is what we got right there, man. So we're rocking and rolling. And the last one on this, probably he does not complete his first 2 passes. All right, now this is he completes it on the first or second. So if the probably he does not complete his first 2 passes would be 1 minus that. So 1 minus 0.903, which would be 0.097. Which is what we got right there. So we're good. Now, which one of these is unusual? None of them. None of them are less than 0.05, so none of these are. Okay. All right, so that's it, man. This is a long video, I think longest ever made, but that's our Chapter 4 test review. So contact me if you have any questions. The test will be similar to this. It might have a couple less problems. But anyway, contact me if you need to. Have a good rest of the day. Bye-bye.